So all last week we were solving one-step equations, correct? It only took us one step to get to our solution. Today it's going to take us multiple steps, 2 or more. Okay? So, 1.4, solving multi-step equations. You can write this down if you want. This is directly from your textbook. It's just the steps that we need to solve our multi-step equations. To solve a multi-step equation, simplify each side of the equation if necessary. Then use inverse operations to isolate the variable. So, it says simplify each side of the equation. What that could look like is combining like terms. That would be a form of simplification that I would need to do first. Do you guys remember the distributive property? Okay. If I've got a number or a variable times a set of parentheses, I would use what we call the distributive property. 3 is being multiplied by x minus 4, correct? Anyone remember distributive property and can tell me how to do this? Yeah, I'm distributing my 3 throughout the whole set of parentheses. So I'm going to multiply 3 times x, which would give me what? 3x. And then I have to multiply the 3 by negative 4 as well, which gives me negative 12. Every single term inside the parentheses has to be multiplied by that number outside of the parentheses for distributive property. Does that make sense? So you may have to do distributive property to simplify a little bit first. Once you get everything simplified as far as it'll go, then you're starting to try to get the variable by itself. Okay? Any questions about this? Can I move on? Example 1. Solve 2.5x minus 13 equals 2. 2.5x minus 13 equals 2. Once again for today, I just want us to focus on solving the equation and not checking our solution for today. You can if you want. If you feel unsure about your answer, you can go ahead and check it as well. Okay, based on this slide, what's the first thing I need to do? What's the first sentence tell me to do? Simplify each side of the equation if necessary. Let's see if either side can be simplified. The left-hand side of the equation, 2.5x minus 13, is there anything I can do to simplify that? Are there any like terms that I can combine? Well, first off, let me rewind real quick. Do we know what I mean when I say like terms? Can someone elaborate on that for me? What do I mean when I say like terms? Anybody? No one remembers or no one wants to answer? It's okay either way. Okay, I'll just explain it to you. Like terms are things that I can combine that are the same thing, essentially. So a constant is a number without a variable. So like if I had 5 plus 2, those are both constants. I could combine those because those are like terms. Does that make sense? If I had a variable in there, 5x plus 2x, the variables must be the same, and the variables must have the same exponents. So are these like terms? Yeah. The variables are the same. They both have an exponent understood to be 1. So I would get 7x there. Are those like terms? Yeah. They're the same variable with the same exponent. What's 3x plus 7x? 10x. Are those like terms? No, why not? Huh? Yeah. They're the same variable, but do they have the same exponent? No. One exponent is 2. One x's exponent is 1. So those are not like terms. I cannot combine those. So I can only combine constants with constants, x terms with x terms, x squared terms with x squared terms, x cubed with x cubed, so on and so forth. Does everyone understand what I mean when I say like terms? Okay. So going back to our original problem, on the left-hand side of the equation, do I have any like terms that I can combine here? No. So I can't simplify it in that way. Do I have any distributive property or anything I can use? No. So is there anything I can do to simplify the left-hand side? No. What about the right-hand side, the 2? Anything I can do to simplify that? No. So, that's why it says, if necessary right here, because it's not always going to be able to, you're not always going to be able to simplify one or both sides of the equation. Okay? So we can't do that. Now we need to start using our inverse operations to isolate our variable. What would I need to do first if I have 2.5x minus 13 equals 2? Add 13 to both sides. What I always tell students is before I can get the variable by itself, I need to get the term that contains the variable by itself first. So here's my term that contains the variable, correct? It has a number on the side of the equation with it, so I've got to get that term completely by itself before I can get the variable by itself. Okay? So like we said over here, we're going to add 13 to both sides. Whatever I do to one side, got to do to the other. The left-hand side, the 13's cancel out. I'm left with 2.5x. Right-hand side, what's 2 plus 13? 15. Questions there? Is the term that contains my variable now by itself? Yes. Now I can focus on getting the variable by itself. Can someone raise your hand and tell me how I would get x by itself here? Very good. Divide by 2.5 on both sides because x is being multiplied by 2.5. Inverse of multiplication is division. Okay, someone type in your calculator 15 divided by 2.5. 6. Any questions on how we got x equals 6? No. Good with that? Yes. All right. Once again, if you're ever unsure about your answer, you could always plug it back into your original problem, and you should get a true statement out of it. Okay? Can I move on to example 2? Yes. Okay, I'm waiting a second. Any questions, comments, concerns, or confusion on this problem? Okay, can I go ahead and move on? Example 2. Solve negative 12 equals 9x minus 6x plus 15. Negative 12 equals 9x minus 6x plus 15. Once again, we need to check to see if we can simplify one or both sides of our equation first. So does anyone see any simplification that I could do? Can you raise your hand and tell me? Yep. How can we simplify those? Or why can we simplify those? Yeah. There are like terms, right? That's our combining like terms part. Does everyone agree that 9x and negative 6x are like terms? Yeah, they have the same variable with the same exponent. Correct? Can my left-hand side of the equation be simplified at all? The negative 12? No. So that's just going to come down. What do I get when I do 9x minus 6x? 3x. I still have my plus 15 that I need to account for. Questions what I've done there? All I've done is combine my like terms. Can I do anything else to simplify either side of the equation right now? Can I combine any more like terms? Do I have any distributive property? Anything like that? No. So now I'm going to start using my inverse operations to isolate the variable. So, raise your hand if you can tell me what my next step would be here. Yeah, subtract 15 from both sides. Once again, before I get the variable by itself, I need to get this term containing the variable by itself first. So I've got to get that 15 away from it. It's 3x plus 15. Inverse of addition is subtraction. Negative 12 minus 15 gives me what? Negative 27. Is my term containing the variable now by itself? Yes, it is. There's nothing else with it. So now I can work on getting the variable by itself. Raise your hand if you can tell me how to get x by itself here.
Divide 3 plus
Yeah.
Divide 3 plus
Yes, very good. Thank you. Negative 27 divided by 3 gives me negative 9. Once again, if you put x equals negative 9, that's the same thing. Go for it. Okay? Any questions on how we got x equals negative 9? If I wanted to check my solution, I'd have to plug negative 9 back into both of my x values. Does everyone see that?
Yes.
And then use your order of operations to work down both sides of the equation. We good with example 2? Questions, comments, concerns, confusion? Can I move on to I think it's my last example.
Yes.
All right. Solve 2 times 1 minus x plus 3 equals negative 8. 2 times 1 minus x plus 3 equals negative 8. Same thing like what we've been doing on all of them. We're going to see if we can simplify one or both sides of the equation and simplify it as far as it can go. Okay? So that left-hand side of the equation, does anyone see anything that I'd be able to do right off the bat? Raise your hand.
the things that are in parentheses.
Say it again.
The things that are in the thing.
In the parentheses?
Yeah.
What would you do with those?
Well, you would times 2.
Very good. Like what I showed you all at the beginning, right?
That.
Well, there. Our distributive property. I've got a number times a set of parentheses, so I've got to make sure every term in that parentheses gets multiplied by 2. Okay? What's 2 times 1? 2. 2 times negative x.
2x.
Negative 2x.
How is that right?
I still have my plus 3. In front of our x, it's like a negative 1. So I'm doing 2 times negative 1x. It is subtraction, but it also makes that value negative. So bring that plus 3 down, and then I still have equals negative 8. Any confusion on how I distributed here? Okay, can I do any other simplification anywhere else?
Yes.
Where?
2 plus 3.
Yeah, I got a set of like terms over here. 2 and 3 are both constants. I can combine a constant with a constant. They are like terms. So what is 2 plus 3? What? 5. Any confusion there on what I've done? Can I do any more simplification here? No. Now I can start trying to isolate the variable using my inverse operations. In order to get the variable by itself, I need to get the term that contains the variable by itself first. So raise your hand if you can tell me what I would need to do. Subtract 5 from both sides. Very good. Thank you. So I get negative 2x equals negative 8 minus 5 gives me negative 8 minus 5? Negative 13. And lastly, raise your hand if you can tell me my last step. Divide by negative 2 on both sides. X is being multiplied by negative 2. Inverse of multiplication is division. So I'm dividing by negative 2. Negative 13 divided by negative 2 gives me what? What is it? 6.5. Questions on how I got that? Questions, comments, concerns, or any confusion? How are we feeling about multi-step equations? Good? Probably not quite as good as one-step equations, right? We like those one-step equations, don't we? But you're going to get harder and harder equations the higher you get up in math. Geometry, algebra 2, calculus, pre-calculus, trigonometry. So we got to start now and practice those so we can get better at them for future math classes. Questions on any of the examples I just did with you? Okay. Here's your assignment. Page 28, 4 through 24 evens. Yep. So you're just doing 4, 6, 8, 10, 12, 14, all the way up to 24. Skip all the odd ones in that range. Okay? This one will be due on Wednesday, the 23rd on Canvas. Make sure you get the correct heading at the top right of your paper. Name, date, period, assignment in the upper right-hand corner. Need those 4 things in the upper right-hand corner. Okay? Are there any questions about the notes before I end the recording?